Hey everyone, day 6 of Advent of Code 2025. So I was not right yesterday about the simulation thing. I guess for today I will guess it is a non-number answer. You know, one of those days where you have to like find a word or find like an image which looks like a word or something like that. That would be my theory for today. We'll see if I can go 2 for 3. It is a bit of a wild one. We haven't had that many, but it'll make it all the better if I get it right, you know? Alright, day starting. This looks very numerical. Oh goodness. That's not looking great. Oh, what in the world? Okay. Cephalopod math. Represented in a long horizontal list. Numbers are arranged vertically. Okay, so you use the symbol at the bottom to add everything, and then you add everything together. Cool. How many rows is it? 5. Okay, so we have list integer row 1. My goodness, can I type? And then we'll just copy this. There are 4 rows of numbers. Wow, I'm struggling here. Okay. And then we'll do string for the last one. Cool. So now we do string r1 equals, actually we probably want a string array. Alright, what is it? Sometimes it's, ooh, that's a bit tricky. Sometimes it's multiple spaces, sometimes it's one space. Okay, I mean, I think it's still fine. We just split on space, and then we'll get rid of anything that's only spaces. Obviously, any actual solution should be using loops for this stuff, but you know, just to be fast, we'll stick with this. Alright, cool. And then we're gonna have a helper method. We're multiplying 4 potentially relatively large numbers together, so I might actually, yeah, I'll use a long int I1, int I2, int. The actual numbers seem to all be ints, so I'm not too worried there. What kind of operators are there? Times and plus, that seems to be it. Okay. If operator dot equals plus, return the sum. Otherwise, we want to return. So we want to set this to a long before we multiply, so there's no actually, let's just copy this. The reason to cast first is I don't want it to overflow and then cast to a long, which kind of defeats the whole point of returning it as a long. Okay, so now for string s in r1. Actually, no, we need to, oh no, we don't. String, I was going to say we need to, the index, but I don't think we do. If s.trim dot is empty, continue, that means we got one of the spaces. Otherwise, we do row1 dot add integer dot parseInt s. Now we copy this for the other rows, row 2, row 3, and row 4. Again, proper way would be definitely to use a loop. this way for now. Okay, and now the final one's a little different. We actually just add s itself. And then for int I equals 0, I less than, we'll just pick a random row. We'll do answer plus equals helper, row 1 dot get I, row 2 dot get I, row 3 dot get I, row 4 dot get I, row 5 dot get I. Cool. Yeah, that's a gigantic number. Cool. They're written right to left. What? Each number is given with this most significant digit in the top and the least significant digit in the bottom. So the rightmost problem is 4 plus 4. So it's both, it's backwards, but it's not upside down. Okay. Well, this solution. Oh boy. Oh boy. So the spacing does matter. Okay, what? But it's always spaced so that like it looks like it's always right aligned. Nope, just kidding. Just kidding. Sometimes it is not right aligned. Okay, okay. So this is actually need to keep these spaces. Yeah, the spacing is actually very important. Okay. How would I approach this? Because it's not just flipping the numbers, right? Because we're reading vertically. Okay, I think it's not too bad. So what we're gonna have to do though is basically we're gonna need a list of sizes. We also no longer want to split on space anymore. I think we just want the line because we're going to be doing a lot of substringing. We'll still split the last row though. Oh no, I just said we're still splitting the last row. Okay, we can get rid of all this. Just doing a quick check to see how big the numbers can get. They don't seem to be able to get that big, so I think it's fine. And our helper will also change slightly. We're going to do a list of ints instead. So then what we will do is long answer equals 0. And then we do for integer I in ints, answer plus equals I. And that will autocast it, so not too much to worry about there. Otherwise, we want to set answer to 1, and then do the same thing, but times equals. Cool. Okay. So now what we're going to do is let's see. So we have all the rows. Well, we have all the strings. Alright, so it sounds like we probably want a second helper, which basically will take strings and generate numbers from said strings. Right, so imagine we have this, then basically what we can do is string num1. Yeah, saying string num1 is so wrong, but all good. So we start at index and we go to index plus length. Why did I do brackets there? So this will isolate the number down. The tough part, we do need to remember to go left to right. Also, are there spaces at the end? Oh, good. Okay, the last number is the same size, so we don't have to worry about weirdness there. But basically, we have all these. We now want to reverse all of them, I suppose. Is there a reverse? No. Okay, that's fine. Is there a string dot reverse? No. Okay, it's fine. We're just gonna do a for loop backwards then. Equals what's this? Num1 dot length minus 1. I greater than or equal to 0. I minus minus. Almost typed plus plus out of instinct there. So now we want to construct a string, but first we should probably have a list here, because basically what we want to do is return helper, right? Helper ints. Oh, we do need the operator. Okay, string operator, ints operator. Cool. So that's our final, but string. So for each one, for each index, we're going to want to construct some string. So we're going to do temp plus equals. We want to go top down, so s1 dot char at I, and then just boom, boom, boom. Thank goodness it's only 4. If this was 10, then yeah, lots of variety. And then basically, now that we have temp, we want to do int dot add integer dot parse int. We're going to do temp dot trim, I think, because there might be a lot of empty spaces. Oh, not s1. We want num1. Yeah. Yeah, theoretically this means we didn't need this. We could just put in here, but it's all good. Okay. So now we actually need to get all the things. Let's see how to do that. Actually, do I even want to split R5? Probably not, right? Let's just go through R5. So for int I equals 0, I less than R5 dot size, not length. I swear I've coded in Java before. Still can't remember size from length sometimes. Okay, so now as we're going through, I guess we have I don't even know if we need cur index, but it's alright. We want to basically get the next thing, right? So maybe we just store the indices instead. If r5.char at I does not equal space, then we can add it. Oh my goodness, stop it. Oh, I don't, nope, it's like that. Cool. So now that we have that, we can do for, I guess the index is this one, right? So we don't really need the other thing. Okay, I'm gonna hard code a little bit here. Given, yeah, the last one, see, like we can't go by number of spaces after it, so we're just gonna manually put in something for that one, I think. I'll try to remember that. So basically for integer I in indices. Answer plus equals helper 2. How close are we to having everything we need? We have R1, R2, R3, R4, I for the index. Not quite. Okay, we'll need one more thing. Can I fake this? I'm gonna fake this. Boom, add a symbol to the end there just so all the lengths line up. Then we do for int I equals 0, I less than indices dot size, I plus plus. We're close. So we have this. We don't want I here. We want indices dot get I. We also don't want the last one. And then the length is indices dot get I plus 1 minus indices dot get I. And then the operator is r5 dot char at I. Yeah, I guess it should technically be empty string plus that. Don't need this. Dang it. Where is this? It's possible for it to be fully empty? Yeah, it sure is. Okay. First thought is this. Whoa, wrong screen. Nope, that did not work. I guess maybe let's just print out the things, right? Like, what are we actually working with here? 84. Oh. S2, S3, S4. Should definitely know that. That is an absolutely humongous thing. Nope, and it's not right. Okay, well, at least we can try the example. No line found. Yeah, good point. So I guess we just fake a line here. Where is it? Okay, what if temporarily we just do some nonsense like that? We get the wrong answer. Dang it. Okay, let's do this, see where things are going wrong. So we have 1, 2, 3, 4, 5, and 6, right? And then we got 8, 5, 4, 4. Well, that's not good. Oh no, 8, 5, 4, 4 is correct. Then we have 7, 3, 2. Oh my gosh, that's so far wrong, right? Because it should be 625. How are we getting 7, 3? Huh? We have 8, 5, 4. Where are we getting 8? What? How are we getting 8, 5? Oh, sorry. 3, 2, 8, 6, 4, 9, 0. Yeah. Huh? What in the world? 3562141 times, yeah. Then we have 8248,369. Great. We have no symbol. Why do we lose the symbol? Huh? Where'd the symbol go? Hello? The operator's just blank? Why is that? R5. Oh, there should be indices. Get I. Okay, I mean that's closer, but still wrong, right? 32638. How do you do 4 off? That's crazy. So we have bet you it's, yeah, how did we lose the 4 in the last one? Oh, it's 1 too close. Is that gonna work? Cool. Okay. So now we undo all the jank we did there. Make sure to add a space and then do the fake plus. And then we need to turn this one back on and try. Well, that's a different answer. Nice. Okay, that was a much harder part too. I mean, I was also bad apparently, so maybe it's not that much harder. But yeah, it's very interesting. I mean, this is gonna take a lot of work to clean up. This code is atrocious, but the concept of reading down is pretty cool. Like spatially flipping the direction, because it's obviously just harder for a computer to parse that way if you don't explicitly build it in. Nice. Well, see you guys tomorrow. I'm now 1 for 3 on suggestions, unfortunately, or predictions, but it is what it is. We're halfway through the event, and yeah, problems are definitely getting harder, so stay tuned. See you.